before continuing, I would like to know how many can follow pure English, or how many people will prefer if I speak in Gujarati, because I am basically Gujarati. So if more people prefer Gujarati, then okay, so we try to complete. See, there are some technical terms or something like that which may be difficult to put in Gujarati, so at that time I will use English. I will try to mix as and when possible. So if there is any confusion, you can interrupt at any time. You can ask any question at any time. So don't worry, don't wait till everything is over and up. You don't wait with your question till then. So okay, I don't. As I said, what I would like to touch upon today is sort of a space-borne research, particularly in astronomy and planetary sciences, and in Indian context. Now the Indian context will come towards the end of it, because I would just like to give some brief introduction to the subject. But before that, I will just start with this slide. This is a tribute to a great legendary scientist. I hope everybody knows. What is most important to realize is that, you know, this was founded in 1947 at age of 28 years. I mean, he completed his PhD in around 1944 in England. He came back. At the 28 year, he is a very young age. Nowadays, in fact, we see a lot of people who are in 28 years. I mean, to realize that we need this kind of institution, and to build this kind of institution, and particularly invite eminent scientists to take charge of it. He was not a first director. I mean, normally, suppose if I found an institute, I would be director of the institute, because that's how I will ensure that everything goes as I want. But it was his vision that he invited a very prominent other scientists from various fields. Professor K.R. Ramanathan. How many people know Ramanathan? No. He was the first director. He was actually a very prominent theoretical physicist, and he gave overall direction to the future of the physical research laboratory. And then Professor Sarabhai, he stayed there as a faculty member and initiated all the space research activities. So all the Indian space research which we see today is because of this man, and because of he was free to carry out all his research activity. Okay, I have spoken too much in English, so now I think I'll switch to Gujarati. No? Yeah. No problem. Okay. So now, okay, I'm just putting, Madam already listed all of them. I'm just listing them again. My point is not to show that what are the experiments. Basically, what I want you to all focus is something, all these reds. This is some X-ray, 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 X-ray. This is radiation, but it's still X-ray. This is also X-ray. So, I mean, basically I am X-ray person, so I like X-rays too much. So, what I will do is, my subject which I mentioned, X-ray space research. Space research is quite large subject. I mean, it's not only X-ray, but what I will most focus is sort of research in X-ray. Towards the end of it, we are open. If you have any question for any other wavelength, I will try to satisfy as much as possible. But as I was saying, most of my work has been in X-ray, so I will try to focus more on X-ray astronomy and sort of X-ray planetary science. Now, X-ray astronomy is a regular subject, mainstream subject of astronomy. X-ray planetary science, as said, there is no separate subject, but I am just conveniently using it because what kind of planetary science generally you do in X-rays. But now, before that, okay, how many people know what are X-rays means? Do I need to go through all the introduction in X-rays and these things? Everybody knows about X-ray. So I can just quickly flip through a couple of slides what I have now. So we all know this. You know why do we see these X-rays? And why does it happen? No. Okay. So anyway, we'll see. Now, okay, what are X-rays by the way? Electromagnetic waves. And what is the difference between X-rays and other electromagnetic waves? Frequency, fine. So that's fine. So I don't need to worry about any of these things, because see, my problem is that I was not aware about your present syllabus, I have tried to make it a little more simple, but doesn't matter. We will have more time at the end for discussion. So you know all this. There is no requirement. So now here, this is an sort of interesting picture which puts everything in context. Like for example, if you know visible band, it's a very small visible band, 400 nanometer to 700 nanometer. If you go on a longer side, we call it infrared, microwave, radio. On shorter side, ultraviolet. This is something called soft X-ray, hard X-ray. Now you see that this is purposefully done here. These edges are not very sharp. So in this region, if you see, sometimes somebody, let's say one particular frequency or wavelength, or in other words energy, 100 eV. You know what is electron volt? So 100 eV is a photon energy. Now if you ask me how 100 eV photon is X-ray, I will say it's X-ray. If somebody is working in ultraviolet, he will say ultraviolet. So these are just sort of a name given to a broad region. There is no hard and fast limit of what is X-ray, what is not X-ray. So in that sense, soft X-ray also has a fuzziness on both sides. It starts from about, let's say 100 eV to maybe 10 keV. So it's a 10,000 eV. Hard X-rays will start maybe about 10 keV to 100 keV or onwards. Why it is important is because some of the experiments, some of my experiments, if you have seen, this high energy X-ray spectrometer, it actually detects gamma rays, but since the energy ranges are same, you call it X-rays. So basically there is sometimes confusion among this time, but what I would like to mention is that essentially what is more important is the energy of the photon. Names are immaterial. So basically this entire range from 0.1 keV to 100 keV is sort of X-ray range. And then when we talk about X-rays, we generally talk about space experiment. And the reason, I mean, you know all, that X-rays cannot pass through very thick matter. Okay, X-rays do pass, but like for example, if you see the atmosphere, you have about 15-20 km of atmosphere, maybe 100 km of atmosphere. So if you have X-rays with lower energy, then they will not be able to pass through our atmosphere and come to the Earth. X-rays of let's say higher energy, maybe 10 keV onwards, can come down up to certain extent. They can pass through maybe let's say upper 80 km of atmosphere, and they can come up to 20 km altitude. So you see, this is atmospheric transmission for the entire electromagnetic spectrum. So it's given in the other way. So wavelength is increasing. So long frequency, long wavelength radio, these are our standard AM or FM radios, they are blocked by atmosphere. So no radio waves can come from outside atmosphere. Same way, if you have some transmission here, it will not go out. So that's why if you see that our AM radio station, old radio station, we could listen to quite far distance from the main transmitter. Whereas the FM radio station, which uses slightly higher frequency or shorter wavelength, they do pass through atmosphere. They don't reflect back, and as a result, FM radio station we can listen only in the vicinity of its transmitter. So this is because of the blockade due to Earth's atmosphere. Then up to this region, let's say most of the microwave region, this is fully open. So all the radio waves, if at all they are coming, I mean, you know, there are radio telescopes and radio comes from astronomical sources and all, isn't it? You are aware about all those things. So that is why all these are on ground. But once you come here in infrared again it's completely blocked. At a very near, this is called a near infrared, there are some few pockets. So if you want to study only within some sharp, narrow wavelength range, then you can do something from ground. But if you want to have a full coverage, then you have to go above space. So that is why this is telescopes which are working on a wide range infrared, they are mostly space-borne. Optical light is a fully transparent, atmosphere is transparent for optical light. So we get all these things. So all your optical telescopes, we can have ground-based telescopes. But you know, there are optical telescopes are also there on space, you know, which is the, you know, any now? Hubble Space Telescope. Galileo, how where did you? Galileo is not a telescope. What is Galileo? No, when Galileo. So Galileo is a different mission which is going to Jupiter. It's not a telescope. Hubble Space Telescope is a proper telescope which is used for observation. So, but still, I mean, if these waves are coming to ground, then why do we need to go in space? There is another question. We won't worry that about right now. Maybe later on we can have some discussion. But as soon as you go beyond ultraviolet, you cannot do anything from ground. So for that you have to go to space. Maybe when you go to very high energies, about 10 kV onwards, as I said, X-rays do come down up to certain extent in atmosphere. So in that case, it is possible to do some studies from let's say balloon. You know, scientific ballooning is a major branch. Are you aware about that? You know from where these balloons are launched, or is there any facility in India? Anybody is aware about it? No. So, okay, maybe actually I will touch upon it a little later. But at higher energy X-rays, this is a very important part. In early days, when there was the sort of space platform was not that reliable, you know, all internationally, all the rockets and satellites and everything started coming maybe last 20-30 years. Was before that, mostly experiments are done by balloons. So, and that is the reason that when you generally talk about X-rays, you have to talk about either, for example, in the case of planetary sciences, you have to talk about some planets, or if you call not planets but some satellites, if it does not have atmosphere, because then atmosphere will prevent you to do any study in X-ray. In proper astronomical sense, you have to still go beyond the Earth's atmosphere. So all this again you are aware. You know how X-rays are generated? You see, maybe okay, I did not hear some unanimous yes, so I spent some time. See, there are basically 4 different processes.